Welcome everyone to this webinar. Super excited about it. My name is Amanda Menking. I am the Director of Programs at TSPA. I'm going to give a quick introduction to what TSPA is. You probably know since you're here, but TSPA is a nonprofit supporting the global community of people working in online trust and safety. We work alongside trust and safety teams to help them develop expertise, skills, and relationships that they need to navigate this really unique profession. We also are a forum for professionals to connect with each other, to exchange ideas of how to do the work of trust and safety, and to find guidance about their own career paths, as well as share their expertise with others, as Matar has graciously volunteered to do today. So who is Matar? Matar leads the Data and AI group at ActiveFence, where her teams are responsible for the data algorithms and infrastructure, which fuel ActiveFence's ability to ingest, detect, and analyze harmful activity and malicious content at scale in an ever-changing complex online landscape. Matar holds a PhD in neuroscience from the University of California at Berkeley, where she recorded and analyzed signals from electrodes surgically implanted in human brains. She said she will not be talking about that today, but maybe that's a follow-up webinar, possibly. Matar is passionate about expanding leadership opportunities for women in STEM fields and has 3 children who surprise and inspire her every day. All right, I'm going to
challenge and teach
and question.
Everything.
So I'm going to hand things over to her. I'm going to turn my video off and my audio off. She's going to give this amazing presentation for about 30 minutes, and then we're going to have some moderated Q&A. So over to you.
Wonderful. Thank you so much, Amanda. I appreciate it. So let me go ahead and share my screen. And you'll see it like this. Now I have to, hold on, do this really quickly. Just presenter view, that's what I want. Okay. So I hope everyone can see my screen. I can't see you, but I'll assume the answer is yes.
We can see your screen. It's great. We do not see your presenter notes. We just see your screen.
That's exactly what I want. I can't have you seeing all my secrets. So hi, everyone. Nice to see you here today. My name is Matar, and I'm, as Amanda said, I'm the VP of Data and AI at ActiveFence. And today, what I want to share with you is how ActiveFence adopts a data-centric AI approach for the development of our detection models. Specifically today, I'm going to be focusing on models that detect hate speech content and text, but this is applicable across the world of sort of AI for harmful content detection or otherwise. We'll just be using hate speech and text as an example. I'm going to be asking you to vote during the presentation here and there. So make sure you know where the, gosh, I don't even know what it's called on Zoom, the reaction buttons are, and then we can do thumbs up and thumbs down. So let's get started. So at ActiveFence, our mission is to protect the integrity of every online interaction, which will lead to a safer world, both online and offline. As we all know, we live in an online world, and our online lives have a very clear effect on our offline lives. And at ActiveFence, we protect 3 billion users globally every day, and really believe that by this, we're doing our part to make the world a safer place. Our clients are basically any platform that has user-generated content, and then we can detect harmful content at scale on those platforms. For example, we detected 45 million items of child abuse, which we reported to online platforms for them to remove in the past year. Every day, we detect about and we report about 2,000 new links to terror content, and these are reported to the platforms for them to handle. And as we all remember in the events of January 6th, but there were about 1 billion fake news items which were viewed in the months leading up to the 2020 elections. And as we all remember from January 6th, this online political misinformation had very, very clear and serious offline effects. And so this is how and why, and this is a very clear example of how by keeping the online world safe, we can do our part to keep the offline world safe as well. Now, how do we do that? How can we mitigate the risk of online harm? We do this by detecting numerous abuse areas. For example, we have copyright infringement, human exploitation, fraud, human trafficking, hate speech, and so forth. And today we'll be talking, like I said, just specifically about hate speech. But before we can talk about that, I want to talk about how we can do this at scale. And really, the only way to keep online platforms safe at scale is with technology. And before we can talk about that, I want to really discuss just the abuse life cycle with you. And so what that means is basically what is the life cycle that an abuse goes through from when it is first comes into the world to when it is fully contained. And so initially what happens is that there's some new threat, right? Whatever it is, something new that we haven't seen before. The first thing that happens is that some policy needs to be defined around this threat, right? We need to be able to say, what is this threat? What is in and what is out? What do we need to detect? What do we need to mitigate? Then there needs to be sort of a new way of detecting that threat, and we'll talk about that in a second. And only then can we start doing enforcement, moderating, and training moderators. And only after all of these steps have happened can we say, okay, the abuse is contained. Now, in order to really be able to do this at scale, and in order to protect moderator well-being, we need two things. One is we need the detection to be very high quality, right? We need to have very accurate detection so that we know that we're able to detect what's out there, and then we're able to do it at scale and to basically find a lot of it. And then what we're doing is we're also protecting moderator well-being, because the moderators are really exposed to much, much, much less, because the detection, the model, the technologies, the automated technology is doing a much better job of ensuring that we can automate and get rid of the things that are very, very clearly violative. We don't need moderators to be exposed to very, very harmful content for no reason. And really the moderators are only there for things that are edge cases or gray or we're unsure about. And then their decisions can be fed back into the model to improve it, so that for the next time, they can only be for the cases that the model doesn't know and doesn't catch. And so really we believe that the only way to capture and to basically shorten the abuse life cycle, so the time from when a threat comes on to when it's fully contained, is with technology. And today we're going to be discussing specifically the part of detection at scale and the technology there. And one big question that arises when we're sort of developing these models and thinking about how to do detection at scale is basically this question of what's more important, the data or the model architecture? And this question is really at the core of model-centric versus data-centric development. And for those of you that are sort of more familiar with machine learning, then you'll know that basically in sort of these classic machine learning textbooks or Kaggle or classes online or whatever, basically what you get is sort of this curated and mostly clean data set. And the data scientist's job is to build the best model for this data set, for whatever the task at hand, for predicting or classifying or whatever. And there's lots of focus around this. So you have like models, so you learn about neural networks and decision trees, you learn about different training techniques, regularization, loss functions, hyperparameter selections, model ensembling, it's endless. And this really was the dominant paradigm for the past decade or even more. And really what this did is it led to massive improvements in model architecture, and specifically in neural networks. And so what we've seen is this explosion in foundational models. What you see here is basically from 2018 to about today. The takeaway here is that there's lots of models, of really big foundational models, and they're big. They have lots of parameters, lots of data. And so what that means is that today, actually, we've gotten to a point where it's more productive in most use cases, to hold the neural network architecture fixed and instead find ways to improve the data that's fed into the model. The question has really shifted from how do you construct the best model, like what is the right architecture, right? How many layers and whatever, to how do I best feed these models so their weights and so what they learn is most appropriate for my task at hand. And that's really what data-centric AI says. It says that model architecture matters less, and the bigger lift in performance, in model performance, will come from the data. And sorry if it's not clear, these foundational models that we're looking at right now are just very, very large models trained on lots of data. And then you can take these, and given your data and your task at hand, you can then fine tune them for specific applications. The nice thing is that most of these, or many of these, are open source. There's no need to go out and build a model or even train a model from scratch to achieve great results. And that means that for most use cases, model architecture is almost a solved problem. So now let's just dive into how ActiveFence implements data-centric AI in practice. What we see here is a high-level outline of our lifecycle in developing models. And again, what we're going to be, if we think back to the abuse lifecycle that we described previously, our focus here is about high quality detection at scale. So remember, like first a new threat comes up, and then the policy has been defined, and then we come in. And so we say, okay, we have a policy. Now we need to build the models in order to detect this threat at scale. So as I said previously, we'll be using hate speech in text as our example moving forward. Here are just a few examples from various platforms, and you can see that they're hateful. So the first one from the account Europe is Rising Official 88, just something anecdotal. 88, for those of you that aren't aware, is sort of like shorthand for HH, Heil Hitler. So clear this is, a hate speech account. And if you read what they're writing, they're using, they're using slurs and sort of speaking hatefully towards transgender individuals. On the right, I hate Jews, pretty obvious. Some of these are also obfuscated. So you can see Jews, which is sort of switched to symbols, the E and the S, sort of using leet speech to try and hide a bit what is being said here. And on the left-hand side, we have an emoji instead of the word. So kill the, and then the nose, for those of you unaware, this emoji represents Jews. So these are all different types of hate speech, some more obvious than others, but this is the kind of stuff that we want to find. So the first step in our training lifecycle is the data scientists need to go out and build the data set, right? And now it's not just any data set, right? This data set needs to be large and it needs to be diverse. And so there's many different approaches for how to go out and build this initial data set. The first and oftentimes sort of the most trivial and overlooked is just external sources with sort of open source access permissions, like these public data sets. And for things like hate speech, for example, it's not that difficult because the topic, there's like there's a lot of research papers about it. And there's also open source curated data sets that are ready for sort of, here's an open source data set for hate speech. And so it's pretty easy to collect hundreds of thousands of examples of different hate speech, different data sets, and lots of languages. However, if the threat is more complex or more unique, then we have sort of two other options. One is ActiveFence. We maintain internal databases as sort of part of our day-to-day operations. And so that's sort of some internal, like if you have an internal source of data, that's something that you can also leverage. And what we also do is in cases where the amount of data is like, it's hard to get, or it's really small, or it's kind of edge casey, then we can go to different sources that for sort of like scrape different forums or other sort of domains where we can sort of enrich our data that way. So great. So we have a data set and we've collected all this data. Now what? So having the data isn't enough. Having a lot of data isn't enough. What we need to do is now we need to label it. But that is an extremely non-trivial step, and we can talk about it forever, but I'll try to limit it. Because before we even start to label the data, we need to understand the labeling policy. Basically, we need to understand what's in and what's out, right? And if you think back to the abuse lifecycle, there's the policy step. And that step is critical because without understanding what's in, what's out, the model will never be able to learn. So let's look at the policy or the definition of what's hate speech. It's imperative, it's super important that the policy is consistent, and clear. Otherwise, the labeling will be inconsistent. Your labeling is only as good as your labelers, and your labelers can only do a good job if they really understand the policy and are trained well. So remember, data quality here is key. We're taking a data-centric approach. So this appears to be a very clear definition, right? It's any communication that disparages a person or a group on the basis of some characteristic, race, ethnicity, gender, and so forth. But what you'll notice is that once labeling begins, you quickly come across edge cases. And these edge cases need to be addressed very clearly and very consistently. Because remember, what our model is trying to do is it's just trying to learn a decision boundary, right? For every data point that comes in, it's trying to understand, is it on this side of my decision boundary or on that side of my decision boundary, right? Is it in or is it out? Is it hate speech or is it not hate speech? And as the model is being trained, it's trying to decide where that boundary is so that new points will be clear what side they fall on. And without clear labels and quality data, then it'll see different examples each time and it won't be able to set that boundary clearly. So I promised you guys you'd be voting. So let's take a minute and vote. are these examples of hate speech. These are 4 examples of chats. Go ahead and find the, what is it called? The reactions button, and click away.
And I think we may have to substitute a reaction because folks may have only a clap, a thumbs up, a heart, a crying, a surprise face, and a celebration. So instead of a down vote for saying it's not hate speech, we may have to say like, I don't know, what would you like? Open mouth surprise face is maybe.
That's good. That's a good one.
This will be the down.
There we go. Okay, that's
down.
what you guys were all waiting for. Right, there we go. Yes, you're right. Okay, so based on the policy that we looked at earlier, these are not, none of these are hate speech based on that policy. However, they all do use slurs. So if my solution was sort of like it's just a simple keyword solution, then all of these would be flagged as hate speech, right? So keywords clearly aren't good enough here. And also it kind of depends on the policy of my platform, right? If, for example, it's a child's platform, then maybe I don't care in what way these words are being used. I don't want them at all. So these are things that sometimes might be confusing to labelers, and any decision must be communicated very clearly and very consistently. But you're right, based on our previous policy, these are fine, right? Because in this case, we're either someone standing up for themselves, or oftentimes like reclaiming a slur, or relaying some event that happened. So not hate.
I think Matar has frozen for a moment. I will reach out and let her know. I'll just take this moment to live answer one of the questions that came up on Q&A. Someone asked if a copy of the slide deck will be provided as well. And we'll come back to that during the moderated Q&A. I'll defer to Matar since it's her slide deck. So you are back. We can see you. We cannot see your deck, unfortunately. Yeah.
Okay, I'm that I'll share my deck. Hold on.
No worries. We're, we've all had these moments.
Someone disconnected the internet, not blaming any one of my kids, maybe. Let me see if I can go back. Okay, so
No worries.
That's not, I don't want you to see that. I'll do here.
No worries.
You go. Okay, are we good?
We're good. How to ensure quality data labeling, and we do not see prisoner notes, we just see your deck.
Okay, so how can we ensure quality labeling? We're back. And so, like I said previously, we can have a full session just on labeling, but I'll give you just some of the highlights. So first of all, from our experience, it's really important to label the data in small batches. And the reason for this is that then each batch can be reviewed by a subject matter expert and basically ensure that the labeling is on track, right? And so to make sure that sort of the labelers understand the task, that there's no mistakes, that there's no drift in sort of their understanding. And then basically what you can have is on a subset, the subject matter experts can review and provide feedback. Even subject matter experts don't always agree. So it's important to have them be aligned, because that way the labelers have consistent instructions, have consistent feedback, and the data is consistent. So even if they don't, if the SMEs don't agree, then you haven't done anything basically by giving your labelers clear instructions, because they're going to be getting conflicting feedback. And we've seen this before, right? We've had experts, and even on things that sort of you guys know what hate speech is, you know what child safety is, and even on those things that are seemingly obvious, they don't always agree. So setting out, you must make sure that there's alignment. And again, the small batches basically make sure that you're adaptive to misalignments and are consistent. Now, another thing is that the labelers themselves should be monitored. For example, what we do is we use control sets. So what this means is that we have a set of data that is not really, really difficult in edge case, just sort of data that should be clear to anyone that's read the policy, and they should know how to label it. And we know the labeling for this data set, and we intersperse these examples along the data that needs to be labeled. And basically, if a labeler makes a mistake on one of these, then it means one of two things. Either maybe they don't understand the policy well enough and it needs to be reviewed with them, or they're just kind of not really reading and just kind of clicking through. Either way, the results of this control task that are interspersed with the regular task kind of help us monitor to ensure. Because remember, the data is not labeled. So just looking at the labeler's decisions isn't always enough. And then the last thing that we do is we take a majority of labels. So oftentimes we'll label with maybe 7 labelers. And then for each text, we'll only take the texts that have a majority agreement. So 5 and above labelers agree. And then anything below 5 will end up going for further review. Either it can go to another batch of pool of labelers, or it'll go to the SME. Usually we take it up to the SME for review. And in complicated cases, this whole process can start off with a lot of back and forth until sort of the wheels are sort of turning the right way and everyone kind of gets into the flow and understands, and then you can ramp it up. But in the beginning, it's small batches, lots of back and forth, lots of review. And really our goal here, remember, we're data centric. We need our data to be well labeled. And even in this, there's going to be mistakes. Great. So we collected our data, we labeled our data. When do we get to do the data science? So FYI, all of this has been data science, but now we get into sort of the hardcore models because that's what everyone thinks is the best. So after the first phase of data labeling, now we're ready for model training. And so the first thing that we have to do is we have to choose the relevant language model, right? Before we can even start training. And remember, there's tons of foundational models. There's lots of architectures out there, and we need to pick the subset of language models, of a relevant language model that best fits our task and our requirements. And so the first most trivial thing is you have to think about, how is your model going to be used, right? What kind of environment is it going to be deployed in? And so the first thing is, does it need to handle just one language or many languages, right? Is it only for English, or is it a multilingual environment? And there's specific models. Some are better for monolingual and some are multilingual. And oftentimes the monolinguals might outperform the multilingual on a specific language, but that ties you down to that language and you don't have the flexibility necessarily for other languages. And so if next week you're going to have to add Spanish, then it's probably not good to start with a monolingual language, with a monolingual model just for English. You might as well start with a multilingual model and train it up that way. So that's the first thing that we want to make sure. So we want to think about the task. What languages do you want to support? And another thing that you want to think about is when your model is deployed in production, how does it need to respond? Is it something that's going to be sort of pre-public, like near real-time responses, pre-publishing for chat messages, right? Does it need to have millisecond response times? Or is it something that's part of like a longer and slower flow? Because that'll also affect your model size. So for real-time responses in production, every millisecond is critical. And you want to make sure that you're not taking an enormous model that can't stand up to those requirements. For example, like one really well-known model, XLM Roberta, it's a multilingual transformer model. It has 3 different versions. It has a base, a large, and an extra large. And the runtime performance can double from base to large, so the time it takes to run. But the superiority, sort of in terms of quality metrics, might not improve that much. It might not be worth the hit that you take on reaction time for a large model based on the performance improvement. So these are all things to consider when you're training a model. These trained models also come with their own choice of tokenizers. For those of you maybe less familiar, a tokenizer, basically what happens is you have some sort of sentence that the model needs to classify. And the first thing it needs to do is that we need to take that sentence and split it up into tokens. And that's what the model can ingest in. And then it does its thing. And the choice of tokenizer is important. So for example, if we know that our model is going to be deployed in an environment where there's emojis used, then we're going to want a classifier that knows how to handle emojis. For example, in this case, kill the, and then we see the nose. If these are my tokens, so kill the, and then unknown for emoji, that's not helpful, right? Because any emoji will get transformed to unknown. So if it was kill the, and then, I don't know, like a dog, then okay, kill the dogs. It's not hate speech. Maybe it's, violence or something else, but both of those sentences would get the same representation in tokens. And so the model will see them as essentially identical, even though the labels would be different. And so then the model doesn't learn anything. So that's another thing to keep in mind, is sort of the vocabulary and the tokenizer that your model is aware of. And finally, you want to think about where is your language model going to be deployed? What kind of language is it going to see in terms of the style? Is it just chats? Is it reviews? So if you have a model that was sort of just, you take a model from the model zoo, often it's called, right? Some pre-trained model, and you say, okay, I'm going to fine tune it. But this model was trained maybe on Wikipedia, right? And you say, well, actually, but I'm going to deploy it on a chat site for teenagers. And so the language is very different. The use of language is very different. So oftentimes what you need to do is you need to take this model and you need to fine tune it to a different domain. You need to sort of pre-train it to a different domain by giving it examples from a different type of domain. So then later, when you fine tune it to your labels data, you'll do a much better job because it'll have seen that kind of data distribution. Okay, great. So like I said, you've collected your data, you've labeled your data, you've picked a model, you've checked the tokenizer, you ensure it's ready for your domain, you've fine-tuned it, and now what? So now you're going to evaluate. Now, oftentimes, if we think back to sort of classic machine learning, then we look at sort of these metrics like F1 score, precision, and recall on a test set, right? We all know you have your training set, you have your test set, and then I train, and I look at my performance on my test set. It's good, I'm done. Now, that's not good enough for when you actually want to have a model deployed in production and it's going to see data in the real world. And it's not good enough for us when we want to detect hate speech or any other type of harmful content. We really need to dive deep into the model performance and to understand where the model is weak specifically and where we can improve it specifically, right? We want to make sure that our model isn't biased or isn't weak in some specific spot. And so what we want to do is we want to really do targeted identification of model weak spots. The first thing that we build, we call them functional tests. So these tests are basically, you take your policy and you really break it down into different functionalities. And you basically ensure that you have coverage of tests for every one of the functionalities in your particular domain. And they basically enable you to track your model coverage. For example, these examples here, we recently acquired a startup called Rewire, and they suggested 28 different functionalities for their hate speech policy. Here are just 3 of them, just for example. And so, for example, hate expressed using a slur, you are just any slur to me, that's hateful. But if you have like a reclaimed slur, like we looked before, that's not hateful. And so really you break down, you say, these are specific types of functionalities that are covered by my policy. And each functionality can be used either for the negative class or the positive class. Now, note that this only should drive home really the importance of a well-defined policy. Because without a well-defined policy, how are you ever going to break it up into functionalities and clearly define what's in and what's out, right? So in this case, we know that slurs are in, non-hateful homonymous are out, reclaimed slurs are out, and this really helps you refine it. You can also use things like this in order to train your moderators, but here we're using them really to evaluate our model. And so again, we're really evaluating a model on subsets of the policy. If the classical metrics that we talked about, recall, precision, I'm not saying they're not important. What I'm saying is that they're important in addition to diving deep and looking at the performance of specific functionalities of the policy. And what we can do is, as we identify, this is an iterative process, as we identify model weak spots, we'll add more tests. Now, another way that we can evaluate our models, so we can look at functionalities, we can also look at diverse data. So I want to test my model not only on one specific type of data like chats. I want to basically try different sources and different lengths. So chats and posts and forums and so forth, right? That's one way. I want to make sure that my model will be good. So it won't only, have perfect performance on reviews, but suddenly when it's, when it's deployed, for example, in a forum or on a chat website, it'll fall apart. Now, it's very possible that you'll say, well, I actually know that my site only has chats and nothing else. So then you'll focus on that domain, but you still want to ensure that you have different lengths and different types and so forth. The next thing that the next kind of test that we do is we do a go, no go test. Here, what we have is we have this set of examples that should never be misclassified, right? This is basically things that should always be hate speech or should never be hate speech. And if the model messes up on any one of them, then we stop. It's a go, it's a no-go. and we need to reevaluate, bring more data, retrain, and so forth. And so in addition to the functional tests, in addition to trying on different types of data, we also have this sort of special set of go, no go. And finally, we have a false positive rate test. So that's why Harry Potter is here, because Harry Potter, the book, should not have any hate speech in it. And so we'll take a book like Harry Potter and we'll run it through our classifier. And then what we can do is we can basically monitor our false positive rate. So how many sort of false alarms we're getting on this data it's unlabeled, right? But it's benign. So we know that any hate speech that we find here, I mean, we can look at it and see, but it should be all benign. We shouldn't be getting hate speech here. So this, Little Mermaid, whatever. So, okay, collected the data, labeled the data, trained the data, and now we've evaluated. And we've run all these different tests. Now, we've done the first iteration, and we've realized that our model isn't good enough. So now we need to come to a point where we decide what actions we have to take in order to improve our model. So hopefully up to here, I've given you some ideas about how to get to building a model, how to test your model. And now I'm going to try and sort of give you some advice about what to do when you see that things aren't working out as they should. So we have three options. We can either relabel our data, right? That's the first path. We can collect more data, that's on the left, or we can augment the data. How do we know what to do? How do I basically maximize my ROI here? So we can expand our data set based on our evaluation results. Okay, that's at the end of the day. Remember, it's data centric. We need to make sure that we have the best data and the most targeted data. And so based on the results, we can do that. So if your model, or if my model, our model, is performing poorly across all the tests, okay, it's just sort of crash and burn across everything, then the first thing to do is that we can use active learning. In this case, what this means is that we can use, we can select the examples that will be most impactful in the next iteration of training and send those to labeling. For example, we can send them the examples where the model is most uncertain about. What does that mean? Remember, the model where we have a classification model, it's outputting a probability, so our confidence score. And so we can send the examples that are basically end up closest to that decision boundary, right? So the ones that the model is most uncertain about, and then we send those out to labeling. We can ensure that those are labeled correctly, because then hopefully that'll help the model. If maybe some of them were mislabeled, they'll fall on the right side and it'll be easier for the model to draw the boundary. Another thing we can do is we can look at the examples where the model is super confident and says, this is totally hate speech, but our labels say something different. Our labels say, no, it's not, right? So either the model is wrong or our labels are wrong. Let's send them out again for relabeling. And then those can have a very big impact, because if they were labeled incorrectly, then they'll help the model learn the decision, they'll help refine the decision boundary. Now, if you're suspicious about your label data quality, which you should be, because even no matter what you do, all the tips I gave you before, getting very, very high quality label data is very difficult. There are some tools that you can use to help you with that. We use a tool called CleanLab. It's just a Python library, and with a few lines of code, you can review texts that might be incorrectly labeled. And there's some other packages out there that you can use to sort of investigate your data and see if it's incorrectly labeled. However, let's say your model is not, it's performing okay across the board, but maybe on some specific data sets, it's not performing very well on some specific types of data. So now, guess what? You get to go out, collect more, scrape more, and send it to labeling. So you need to go out and basically say, okay, my model crashed and burned on reviews. I should go collect some review data. And finally, if we see that a model has poor performance on specific functional tests, now is the time you need to augment data. Now you need to create data to address those specific functionalities. And so that's what we're going to talk about next. So now we'll talk about, we went through there and we're going to do data augmentation. In data augmentation, we have two primary techniques. The first is manual and the second is automatic. And so what you're looking at here is our active score, just our interface for our risk score engine. And what we do basically is we can start manually generating adversarial data to fill in the data gaps. And so basically for specific functionalities where the model did not perform well, we can start just sitting in front of our API and in our test environment and generating adversarial examples to try to trip the model up. We'll look at the functional tests, and that basically is what directs us for what to generate. It doesn't necessarily mean that the data scientists need to sit and generate the data. They're often not that great about it. But SMEs can do a really good job because they really understand the policy, and they can say, okay, this functionality isn't good. Here's some examples. Here's what should be in. Here's what should be out, and then label them. And if it's possible, even you can go out and online find examples of those functionalities, and then you get sort of more diversity as opposed to just us having to generate it. So that's sort of the manual path to do it. How many of you guys have tried to use large language models like ChatGPT to generate synthetic data, maybe harmful data? How many of you guys have tried to do that? So thumbs up versus like screaming face. Okay, so mixed bag. So I'll say that these models, especially the proprietary ones, are getting better and better at blocking attempts to generate hateful content. And specifically, I'm focusing on hate. There's a lot of talk about this right now. We can do a whole another session about that. But we can use these models to generate synthetic data. And it's, like I said, it's not always easy to generate offensive examples, but it's very useful for generating benign data. So data that the model will falsely detect as violative, and then you can send that off for labeling. So this example here shows how we can generate legitimate examples with a potentially vulnerable term like transgender. And oftentimes in sort of these open source data sets or data sets that we collect, the term sort of transgender is used, comes with the hateful label, right? Because the examples that we see are oftentimes using that term in a hateful context. And what we can do here is we can sort of offset that bias by generating non-hateful terms about minorities or other targeted groups. And then this can ensure that our models aren't biased to detect hate speech every time those terms are used, right? So I hope that makes sense about how I'm trying to combat bias, right? I'm saying, okay, maybe it's difficult to use these language models to generate hateful speech, but I also need non-hateful speech that's realistic and that covers these vulnerable terms, because that way I can make sure that my model isn't biased. So it doesn't learn that every time the word Jew is used, that's hate speech. Okay, great. So we filled in our functionalities. We collected more data. We labeled. Our model is ready to go. It's in production. We're going to deploy it. Boom. But we didn't think of this. Is this hate speech or not? Go ahead and vote. Thumbs up and like screaming face, yawning face. I don't know, surprise face. Not hate speech. That's surprising. Based on our policy before, is it not hate speech? Is it hate speech? What about it is hate speech? Okay, could be, right? It's like if it was against any minority group, right? What about now? Now that we know that it's from a review side, is this hate speech? Maybe not, right? So one thing that we see, yeah, I agree. It's not, right? That they're talking about food. So one thing that we need to think about, remember, as we said, when we're starting out, and all the questions that we're asking ourselves is like, where is this going to be deployed? And so what we use ongoing feedback for model fine-tuning. What you're looking at here is a screenshot from our trust and safety operating system, ActiveOS. And basically what we do is we take the moderator decision as feedback to improve our model. And the example also showed a gap in our data domain coverage, right? We were missing reviews. When we trained our model initially, this is a real example, we didn't think about the reviews use case. And so we didn't have any of that data. And as soon as we put it in production, we kind of realized that, whoops, we had a giant blind spot. And so we ended up having to both augment and collect data and to improve our coverage and our distribution. So hopefully now we can come back to our question, and maybe I've managed to convince you that the importance of data. And as we discussed today, there's lots of open source models with infrastructure that you can train them. And I've talked a lot about data and how data is so important, and given you some concrete tips and techniques that you can use when you develop your next model to ensure that it's robust in production. If you liked what you saw and you want to learn more, we have an engineering blog that I recommend you visit. We talk a bit about bias, about how we deploy, about how we shift left with our quality and so forth. So come visit us online. Thanks.
So fascinating and so good and so pragmatic, and just really like amazing applicable content. So thank you for that. We have some questions in Q&A. Most importantly, someone said, but what about muggles in Harry Potter? Is that hate speech?
Yeah. Oh no, the chat was closed. I even had a note for myself, keep the chat open. So actually, like, that's a really good example. And I'm going to take it like to a more serious point, is that actually look at your data, right? Always look at your data. And so I just today I had a conversation with one of the data scientists of how important it is that, you know, dive in and look and do error analysis. And so you run it on Harry Potter, and maybe you do see hate speech, and maybe the way that they're talking about muggles is disparaging. Like, I don't know, maybe I had muggles in my training set and I didn't even know. Like, look at it. Is it really a false positive? Is it not? You never know. Yeah, I see a question about
data.
Pardon?
Yeah. Yeah, I was gonna say your answer is go back to the data, but yeah, go ahead and answer this one too.
Yeah, definitely go back to the data. So what's the hard part about labeling data? So is it the manpower needs? No, I think that the hardest part is ensuring that the policy is clear and that it's easy to follow, and that the feedback is clear, and that sort of the labelers are consistent, and that the quality is monitored, and sort of that. I think that's that's difficult, right? Because when you're starting out, what may seem like a very, very clear policy, when actually it's, you know, it's broken down to trainings, then you can find gaps there. And then when the training is taken to the labelers, and then you see data in real life, the edge cases abound, right? Like the exceptions are more than the rules. And so I think that's sort of the bigger challenge there.
I want to jump in and ask a question that I was thinking about before we get to some of these other questions that's related to this. So several different times you mentioned that in your presentation about it's really important when the policy is drafted, and the specifics of the policy and how clear the language is, and thinking about the boundaries and use cases and edge cases. So what about collaboration between data scientists, right, and folks who are drafting policy, that cross-functional collaboration? Is that something that y'all do? Is that something that you advise that people do, that data scientists are actually brought into that loop, or even labelers are brought into that loop early on, even as the policy is being drafted?
Yes, I think that's excellent. And that is what we have actually is even in our so we practice Scrum methodology in the way that we work and then we develop, and we have teams, and our teams are heterogeneous. And so actually in our meetings of our data scientists, when we're starting off with a new model, and even consistently, we have sort of our data ops manager in the meetings with them and our policy manager in the meetings, because questions come up, or sometimes the data scientists will look at a policy and be like, this is impossible. Like, no model can do this. This is inconsistent. Like, how, like, this doesn't make any sense. And so, and other times they're much more positive, but you know. So yes, absolutely. It's an ongoing conversation. And again, it's an iterative process. Like, it's not that the policy is done, the book is closed, move on, next. Like, there's no waterfall here, right? It's very iterative. It's very collaborative. Absolutely. Yes. And our labelers actually will ask questions of our policy managers, and like proactively. So not only like monitoring, giving feedback, but sometimes they'll see a case and they'll be like, is this in, is this out? This is a cartoon of this, or, you know, all kinds of cases where you're like, well, and then the policy is expanded and the examples are, you know, are documented.
Right.
Yeah.
So we have some other questions. We'll start with one that I think is going to be a yes or no, or maybe you will get back to us. Will a copy of the slide deck be provided?
Excellent question. It's not entirely up to me, so I will get back to you on that.
Okay, great. So the next question in Q&A, and folks, we have a little bit more time, so if you have more questions, put them in. So the next one is, how do the role of ops teams change or evolve with the use of AI, specifically data-centric AI? How can ops teams add more value in trust and safety cross-functional decisions? What's the typical timeline of model training lifecycle? And just to shout out to you that it's super helpful and a clear overview, and this attendee learned a lot. So that's a few different questions. So
Yeah.
I see one about the role of ops teams, particularly around AI, and then how can they bring value to these cross-functional decisions, I think are the two main questions.
Mm-hmm. So first of all, I'll say that this has been really fun. And if anyone has any questions or follow up later, just like LinkedIn or whatever, happy to engage and to answer more and to talk more. As you can tell, I think this is super interesting. So ops teams, data ops teams specifically, are critical. Like, we cannot move a millimeter without them. They basically ensure that we have the data that we need to work on it, I think what's interesting is the use of AI by ops teams to sort of, sometimes you can use it to, whether it's to iterate on policies and give examples, or that they can use it to generate data that then is sent for human review and for labeling. So there's like a really interesting human in the loop here. But I strongly believe that even with like these giant advances in AI, you need a human in the loop. You need someone to look, to moderate, to label, to give feedback. I think it's important. Maybe that's kind of tangential to the question. In terms of ops team adding values in trust and safety, cross and functional decisions, I'm specifically focusing on like the data and the AI in terms of trust and safety, and the policy. And I think like we said earlier, and like you had asked, Amanda, is that ops teams are super important in this process of crafting the policy. Like, our ops manager reviews the policy from a policy manager. Like, it's not only that like they'll find mistakes, but they really like go through, and it's this sort of, there's a lot of value there. So I think the people that are closest to the data provide the most value. You know, my unbiased data opinion, but and then what's a typical timeline? It depends. It depends on the quality of the data. It depends on on the labeling. It depends on, is it text? Is it image? It depends on the violation. But you can look at like, gosh, I'm very careful. I don't want to say something and then people are like, ah! So like weeks, you know, like multiples of weeks or months. But remember, it's endless, right? So you have a model that is really, really good and it's out in production, but we're in an adversarial landscape, right? So as good as we are, someone out there is going to try to find ways around it. So new types of lead speech, new slang, new hashtags. And so the model development process actually isn't ever done. So even if, you know, you worked on a model for months and it's out there and it's ready to go, there is always, and we always do, we do retrainings, right? Like I said, from moderator feedback, from the fact that we also at ActiveFence have intelligence researchers that are sort of really have their finger on the pulse of whatever is sort of the latest trend in hate speech or child safety or whatever. And then we make sure to sort of take that intelligence and translate it to data that we can use to train our models. So a data scientist's work is never done.
You give the answers. I used to be a high school teacher and still teach occasionally. And I always say it's the answer my students hate, but it depends, right? There's so many factors and variables, and language is always changing, right? So yeah.
So it actually, it doesn't even depend. Like the answer is never, right?
Never,
like
it's never done.
I mean, I think that we're really, really lucky in the space that we're in, because it's super, super interesting, both technologically and also just like the domain, right? The fact that it's changing, the fact that it's adversarial. And we also get to know that we're doing something incredibly important, right? We're not out like selling air or something. Like we're doing something really, really, really important. And so it's kind of this like perfect combination.
We have a few more questions I want to get to before we close out. So someone said figuring out labeling is hard. Is there some manual or documentation of best practices?
Huh. Good question. Maybe we should write a blog post about that. I think we'll rise to the challenge. I think there's lots of different takes on it online. But I think we'll go ahead and write something up maybe and then share it. That's I'll take that.
All right, action item. You came away from this webinar with an action item. We have another question about policy development. So from a policy development perspective, besides being clear and easy to follow, are there any other characteristics that make a policy easier to break down into respective parts as you described, any tactical suggestions from your experience reviewing policies for the purpose of training models? So I think maybe some key guidelines.
Yeah,
that would help.
that's a challenging question. I think what I've seen is that it's most critical to have a policy that actually has examples baked in. And from that really we can also derive the functionalities. And I think that's important, right? Like when I see a policy, it's like, okay, give the policy and give examples and break it down. Now, I'm not an expert policy manager at all. And I'm sure maybe you guys have had webinars with people like of like, what is the right way to look at policy and sort of construct a policy. But I can say that from our end, like as a data scientist, when we're sort of trying to collect data and sort of reviewing, sometimes we review labels and stuff. Again, I'm not an ops manager either. It's the examples are the most helpful in that. And then like actual, like, so that the policy will actually be broken down into functionalities, like that's gold, right? Like then when we're building the functional test, it's very, very clear for us, like, this is what the policy means. These are the functionalities.
And I will say, we do on the TSPA website, there is the redirect is curriculum.tspa.org. I was about to put it in chat, but it's pretty easy to remember. We do have curriculum that's written by trust and safety practitioners, and there is a chapter there about creating and enforcing policy. It may not get into all of the tactical suggestions, but just want to point to that as a resource. And that's free and available to everyone and anyone to check out there. There's one more question, and I will defer to you whether or not you can answer this, Matar. It may be something that you are not in a position to answer. So a question about your preference on outsourcing as labelers. Understandably, that may not be something that you can speak on behalf of ActiveFence, but do want to note that there is a question about that.
Yes, I think that I'll have to skip that particular question about like how exactly we do it behind the scenes. We use a diverse set of tools to ensure that we get quality labels.
All right. We are coming up on the hour pretty quickly. If anyone has one last question, we could probably take one last question, but otherwise we're going to move to closing out the webinar. Any final question about Muggles or
The Little Mermaid?
The Little Mermaid, or anything else that folks would like to answer? All right.
So I'll take a moment and I'll thank you for inviting. I'll thank you for inviting me. I had a wonderful time. These questions are extremely thoughtful, and I even have action items now. So thanks a lot, everyone who chose to attend. I appreciate it.
Yeah, thank you so much to Matar for volunteering her time. Just a recognition that it isn't just this hour, right? She had to prep the deck. We had several meetings about just logistics. So it really is an investment of hers for several hours to do this. This recording will be available on TSPA's YouTube channel, and Matar has graciously offered, maybe not for the entire internet, but for some folks to reach out to her on LinkedIn if you have questions. So just yeah, give a round of applause for this amazing presentation. And check out TSPA for more events such as these and more resources. Thank you all so much for your time.
Thanks, you guys are great. Appreciate it.
We're going to turn off the recording.